for in this kind of method, we needn't to we needn't to build another activity diagram for the settle chait, but you can also build. It will depends on the necessary. But if you replace it using more detailed activities, then you should also replace here because they are at comparable levels. And if there is more than one successor to an activity, each arrow may be labeled with a condition in square bracket, for example, failure and so on. For example, here, this is called the branch. A daemon is used for representing branch, and each branch, each output is labeled by a bracket with conditions, bracket conditions, and for these two conditions, usually we need one condition is satisfied, the corresponding activity will execute. It means that if this satisfied, it will go to here. If this satisfied, go here. And if no condition is satisfied, the system is badly formatted and the system will hang. So you need to check, is there any problem? And as a notation convenience, a diamond shows a branch into multiple success. And if multiple conditions are satisfied, only one successor activity executes, but there's no guarantee which one it will be. Usually, it indicates that there is some error. It means that usually only if two conditions satisfy simultaneously, maybe you should consider maybe there is some problem or designing problem here. Usually we only at the same time only one condition satisfied. And if there's no one condition satisfied, there's problem with the system too. Initiation and termination. A solid circle with an outgoing arrow shows the starting point. Means the initiation, and bullseye shows the termination point. Bullseye, the start, solid circle start, bullseye. There may be one start and multiple end. And concurrent activities. Organizations on the computer system can perform more than one activity at a time. It means that usually, because for the system software we want to build the especially for the computer system, sometimes it is distributed system. For the distributed system, they can perform some they can perform different activities concurrently. So when we are building the activity diagrams, we should consider the concurrency among different activities. It means that one activity may be followed by several concurrent activities, and these activities may merge into a single activity. A fork or merge is shown by a heavy line with more than one input arrows or more than one output arrows. This is a split, this is a merge. This means concurrent activities. And synchronization control must be present on all of the incoming activity and control passes to all of the outgoing activities. It means that when there are concurrent activities, and before the incoming of the after the control flow past the heavy line of the fork, it means that the control is passed to all concurrent activities, and all of these concurrent activities are executed simultaneously, and then only when all of these concurrent activities has finished, then the control can pass through the heavy line, means pass through the merge line to outgoing activities. If there is one activity failed, then the control cannot pass through the heavy line, means cannot pass through the merge line to outgoing activities. It means that the split or merge heavy line has a function of synchronization. Only when all of them have complete, then the control can go from 3 different branches to here. After the combination of control flow, it will go to the outgoing activity close order. Only when all of them have finished, it can go to close order. This means this is a synchronization function. An activity diagram can also be used to show the progress of control during execution. It means an activity token can be placed on an activity symbol to indicate that it is executing. And when the activity finishes, the token is removed and placed on the outgoing arrow, then go to the following activities, and multiple tokens can arise through concurrent activities, and then after the merge heavy line, the token will decreased. The number of tokens will decreased and migrate from all of the concurrent input activities to the output activity. It means that this is a kind of graphical notations to display the execution state of this activity diagram. It means that we can place some tokens on the activity to show, okay, why has it been finished or it is being executed. Then after it finished, the token will goes along the arrows to next activity, and when the next activity finish, it will go to the following activities. And this is the guidelines for the activity models. Activity diagram elaborates the details of computation, or the details of algorithms, or it means that it's used to display the details or show the details of an operation or business process. And the activity diagram can help developers understand this kind of complex computation process by graphically displaying the progress through intermediate execution steps. It means that through all of these intermediate activities and the sequence of these activities, we can understand it better. Here are some tips. It means don't misuse activity diagram. Don't consider activity diagram to be flowchart. The activity diagram can represent concurrent activities, but it is different from the flowchart. And level diagram, it means that activities on a diagram should be at a consistent level of detail. Just now we have explained that, for example, for the execute on order or settle on order, they are at comparable levels. And if we replace one activity using more detailed steps, then we should keep the if we want to keep the balance, we should replace all other activities at the similar level. And the third is be careful with concurrent activities. At least one must be satisfied when we have some branch or have some, if in the concurrent activity, if there are conditions which we must guarantee that at least one branch or one concurrent activity, one condition satisfies, and it's recommended that we use the else condition. It means that when all of the conditions don't satisfy, then the else will satisfy. And the last is consider executable activity diagram. It's this kind of executable activity diagram will help us to understand the system better, because it can gives us a very clear view of the execution process of the activity diagram. It will show you which one will execute first, and then where is concurrent, and when will it finish, or how to go along the whole activity diagram. So in this chapter summary, the interaction model provides a holistic view of behavior. It means how objects interact and exchange messages. At a high level, we use case to partition the functionality of the whole system into discrete pieces meaningful to external actors. It means use case is used to divide the whole system into different pieces, and then we can use scenarios and sequence diagram to elaborate the behavior of each use case. It means using scenario sequence diagram to help us understand the message transformation or message transferred, the message sequence of among different actors and the system itself or different objects, to elaborate the behavior of different use cases separately. It means that for each use case, we may have multiple scenarios and multiple sequence diagrams. At last, for the activity diagram, it will specify the details of a computation. It don't focus on the objects. It means it doesn't focus on which object performs the activities. It only focuses on the sequence of activities. The activities in the single activity diagram may be performed by different objects or different